Hello everyone, now I will show you the full way from the idea and dataset to the MVP of your machine learning project with the Telegram bot to communicate with your uh, clients. And so what we need to do, we will use this fast benchmark bot. And what is our project? So let's assume we are data scientists at the clinic, and our colleagues, doctors, asked us to build the model which will predict this one death event, so they could understand which patient need more attention. So let's get this data. I have it already downloaded here, and what we will need the fast benchmark bot, so we can click here and move to the bot. So bot is here. Let's push start. We need to install all those libraries, just copy and paste it into the command prompt, and we also need Python, so I have this all already, so I push ready command. And here is my make.json, which will make a structure of my data. So let's put it here, and we will start it. To use it, we need this command. So I'm in the same directory, and now I need to provide a target variable. My target variable is here, and I need to give him my CSV location, and it's here. Okay, so we have this structure, and let's send it to the bot, and we got the report. Let's look at the report. So let's start Jupyter Lab. It's started, and we have this report. Let me just fix one thing. Let's say let's equal 15 to be more beautiful report. So it's reading the data, dealing with problems in CSV and so on. So here is how our data looks like, all our variables here, and what else? Here we have the pair plot. So here is the connections between all our variables here, and name function, encoding function, so you can make your one-hot encoding and split your category into split your variable into less categories and so on, and you can do it very easy and fast using this function. So here is our target variable, here is its distribution here, and all the other variables. So here is all the statistics. It may help us to do some feature engineering later, but let's first look at the prediction. So it already made a prediction for us. Here is the feature importance and and our prediction. And this is how it looks like, and it looks very good, and actually this is, I think, a very good score, so I guess we can't improve it, but we can try. Let's look at the prediction on the real test set. It's actually better, but let's do some feature engineering and cross validations here. So after I looked at all the data here, I don't need to make this plot again, so I will not make it again. So let's go to feature engineering section, and what I see here is this time variable, which is the most important, and let's look at this variable. So this is a follow-up period in days, so maybe it depends on the age. So let's say let's divide this time by age, and we'll call it where is, oh, here we are. So we'll call it data time per year, and it is data time divided by data age. So the idea here is that if the patient is old, this time could mean the problems with other diseases, and if he is young, it is the time only for our disease. And maybe it will be helpful, maybe not. We'll just check it. So we'll also try to tune categories, but it will try to one-hot encode all the categories and check if it will improve the prediction, but actually all our categories are boolean, so it will do nothing. It will just show us an initial score. Let's restart it. It will show us only initial score here. It is the score on 5 different cross validations, so it is much better than our score on just one test set. Securities, it is a little bit lower, so while tuning the model we could have a little lower prediction for our test set, but it will be more conservative, so on the new data it could work better. So again, the same for model. For different for 5 different cross validations, it will check different approaches, tree methods, different subsamples, different max depth, and so on, and it will you know, it will find the best set for our model. So let's check this. I don't see really good improvement here, but some improvement could be, and this is again improvement on cross validations. That means that the model will work better with the new datasets. So as it finished, we got the prediction. The result is a little lower, but it's still very good, and we have more conservative model, which is also very important. So okay, now we have the model, but our colleagues, doctors, when they could not use our model like this because they are not Python programmers and so on. So we need to make a service out of our prediction, out of our model, and we will also make a Telegram bot which our colleagues will use. So it just sounds like a big deal, but with past benchmark it is very easy. So let's stop this, make CLS here, and let's look at the bot. So the bot said that now you can make a service out of your model, and you need to use this service command. So here is the Python file which will generate the structure to our server. It will get the structure of our feature engineering and so on, and will generate service. Okay, so now we need to use it the following way. So we need target variable name in the IPython notebook location. So our target variable name is here, and notebook is here. And let's generate it, and we got it. Let's send it to a bot. And we got this service code, source code, and the documentation for our service. Let's look at the documentation. So here is the set of data we need to give to provide to our service to get the prediction, and here is how to start our server on our service on localhost, and here is how to start it on different host and port, and here is how we can use it from the Python apps. You can just put it all put this into some loop, and got the predictions as a result. So result will come. We'll have the prediction part and probability part. So for classifications, probability part is very important. So if probability is really close to 1, we can believe in this prediction, and if the probability is around 0.5, that means that the prediction is not very good, so we will need to check it somehow. Okay, so now we have Telegram bot code, but as we will start the service, it will generate a bot for us. So we will use a generated bot, yeah. So let's copy and paste this to start the server, and it started. So it tested how it can predict, and after that it started. Okay, so now we should have the source code for bot. It's here, and let's look at this bot. So what we need to provide here is the token. So we need to register our bot and got the token, and to do so we need a bot father. So what he can do, he can register new bot, and let's give him a name. So the name will be heart failure prediction. So it's heart failure prediction. predictor. Sorry, predictor. Okay, so let's now give him a unique name. It should have what at the end. So we got it, and this is our token. And now it can work, but we need to specify questions so our colleagues, it will be easier for our colleagues to use it. So first is age, so let's change it to how old is your patient. So next is anemia, and let's look at the data description, and we will just copy and paste it to our bot as a questions. Okay, so this one, and we'll move through all of the variables to specify questions for those variables. It will take some time, but it is much better than to make a bot from zero, you know. So all you need to do here is just provide the token for the bot and specify its questions. So the number of questions equals to number of variables, and the answer on each question should be the should be this variable. And yes, and to next question. And after we will tune the questions, we will tune also the answers for categories, because you know, okay, this gender, let's ask the gender. Your patient gender. And so really we will specify also the answers, because these answers of zeros and ones are not intuitively understandable. So we'll change it a little. Okay, so oops, we need to say days. Okay, so days. Okay, so we got all of this, and now we will tune the answers. We will decorate the answers actually. So we have this question for anemia, and the values is 0 and 1, and let's decorate it a little. Let's say that 0 is no and 1 is yes. And let's look at others. So it's diabetes, again no, no, and yes. And blood pressure, again no, yes, if it have high blood pressure or not. Okay, so now we have this gender variable. So let's look here. It's woman or man. 0, 1. It's pretty hard to understand, but I think 0 is woman, 1 is man. Okay, so female. male. Okay, so now let's go to smokers. So 0 for no, 1 for yes. And we are almost done, but we need to maybe add some description here, because what we'll print here is the prediction and its probability. But actually that could not be easy to understand maybe. So let's add a little description here. So we'll say if the prediction is 1 and probability is close to maybe we'll say is above 0.8, I think. The patient, what does it mean? That means that he have a very high risk of death, so the patient needs more attention. Okay, so and after that we'll just say how to start a new session with a new patient. So push start command to start 2 3 start I'm going to start new session. Okay. So we done all of that, and we now can check how it works. Let's close it, save, and let's just run it. So we have a service, it's on the local host. So now we can start the bot, which will communicate with that service and with your colleagues and clients and so on. Okay, so let's start the bot. It's started. Now we need to find it. Okay, to do so we need to search for it, and we have this bot. Let's say start, and our question is how old is your patient? Okay, let's just try to someone here in the dataset. Let's take this one. So let's say, okay, maybe like this. Okay. So how old? 55. So 0 is no. So the data here is like this. So again 0 is no. Here 38 and 0 is no. And let's look the other data. So it is here the next answer. So let's say, oh, what is that? Okay, it's 263,358.03. Okay, so level of serum, it is 1.1, and here we got this, and one is for male, and smoking, no, 0 is for no, and follow-up period in days is 6 days. So let's say 6 days. And we got the prediction with pretty high probability, so actually the prediction is like it is in the data, but the probability is not very high, so maybe because this time is really low and we need to look at this patient more. But actually this is how it works. You started from the idea that you can predict this death event from the data from patient medical card, and you just build the model, made a service out of your model, and made a Telegram bot which your colleagues can use, your clients can use, and this is a real MVP of the real data science project. That's very easy, and it took less than 30 minutes from us, and that's all thanks to FastBenchmark. So make data science fine again, and bye bye.